This is lecture 31 based on third unit for the subject digital signal processing. And in this lecture we are going to discuss about this FIR designing using Hanning window method. Okay. So, in previous lecture we had discussion on this some numerical problem based on the FIR designing using rectangular window. So, there is another method that is your Hanning window method. So, we will discuss about this what is this Hanning window function and how we can solve this numerical problem based on this Hanning window method. Okay. So, let us start with this numerical problem. Okay. So, if I talk about this Hanning window function, the Hanning window function is given by for when we have causal. So, the function is WHAN Hanning W Han and 0.5 minus 0.5 W 2 pi n upon m minus 1 cos 0.5 cos 2 pi n upon m minus 1 when this n is lying 0 to m minus 1, otherwise the function is 0. And for non causal Hanning window function, we have this function is W Han and that is 0.5 plus 0.5 cos 2 pi n upon m minus 1 and n is lying 0 to m minus 1 by 2, otherwise the function is 0. Okay. So, for causal and for this non causal only changes this sign. Okay. So, you can check over here this sign. Okay. So, in for causal that is minus and non causal that is positive. Okay. Now, if I talk about the procedure of this calculation or this designing of FIR using this Hanning window technique. So, the process is same whatever we have used in for rectangular window, we can also use for calculation with the help of this Hanning window. The only change of windowing function. Okay. There was WRN equal to 1. Okay. Here we have this Hanning function. Okay. So, let us take one example because the process is same. So, no need to discuss again the process. Okay. So, let us discuss about some numerical problem. So, let us see the question is given or designing problem is given. Find the magnitude and phase response function of 7th order low pass filter with cutoff frequency 1 radian per second using Hanning method. Okay. So, again the filter in the question is same. Okay. The first in previous lecture we took the example. Okay. But the only change is using Hanning window. Okay. So, we know the generalized function of this low pass filter response. Okay, H d is to the power j omega equal to 0 to e to the power minus j omega tau when this lying between the minus omega c to omega c. So, from easily we can calculate this tau because tau equal to m minus 1 by 2 and here the order of the filter is given 7. So, m will be your 7. So, we can have this tau equal to 3. So, we just put over there and we have also this cutoff frequency that is 1 radian frequency, the value of omega c. So, just when we put all these values we will get this equation that is h t e to the power j omega equal to e to the power minus j 3 omega when omega c is lying between to minus 1 to 1 not sorry not this omega is lying between to minus 1 to 1, otherwise the function is 0. So, we can easily calculate the value of this HTN function for taking with the help of the taking inverse TTFT. Okay. So, we know the formula. So, the question is remain same. Okay. So, because till now we did not use this Hanning function. Okay. So, at this point the question the solution of this question which we had discussion in last class, this is the same. Okay. Now, for obtain Hn. So, now we know when we want to obtain this Hn, we have to multiply this Hdn with your rectangular with this window function. Okay, window function which you are going to use. So, here we are using this Hanning window function. Okay. So, we know this Hanning window function. Okay. So, for causal, that is WHAN, and that is 1 by 2 minus 1 by 2 cos 2 pi n by 6, that is the m minus 1 0 to m minus 1. So, m equal to 7. So, just put this value of m minus 1 over here. Okay. So, we have this function WHN. Now, we have these values from 0 to 6, because this n is going to 0 to m minus 1, m is 7 is given. So, this n is varying from 0 to 6. So, just put these values, different values in this equation. Okay. Okay. For 3 we have already calculated with the help of this L'Hospital rule. Okay. So, for calculation of, just put n equal to 0 here, n equal to 1, n equal to 3, 4, 5, 6. So, we will get these HDN. Okay. Now, we know this WHAN for n equal to 0, 1, 2, 3. So, just put n equal to different values, we will get this Hanning function corresponding the Hanning values, and we know this HN HDN into window function. Okay. So, we will get these values. Okay. Now, if you want to calculate means, if I talk about the function, generalized function was this one. Okay. So, if you want to calculate this, okay, this magnitude. So, obviously, the mod of this function will give you the magnitude, and the angle of this function is will give you the your phase. Okay. So, in this question, that when this h d e to the power j omega equal to given e to the power minus j omega 3. Okay. So, you can check over there is only we can write it down this function into 1 into e to the power minus j omega 3. So, here the real part is 1. So, magnitude part is 1, and for calculation of this angle we can use this e to the power minus j 3 omega. So, that is angle is equal to क्या होता है phi omega, and phi omega equal to minus omega tau. We know this formula. So, when you put this value, okay, we will get this, because tau we already calculated, that is 3. So, minus 3 omega will be your angle response. Okay. So, that is the numerical problem based on this Hanning window. Okay. So, this is just about your Hanning window. So, you have to remember only this function, okay, for causal and non-causal. Okay. And the rest procedure are same as the rectangular window function. Okay. So, thank you students.